Hi students, in this lecture we are going to discuss damped harmonic motion. So till now in many problems we have taken the assumption that energy of the oscillator is constant. Here energy means it is only potential plus kinetic, means mechanical energy of the system is a constant. But practically this is not possible because due to many reasons like friction, maybe air resistance, or due to some other reasons, energy of the system will be lost. So because of this, amplitude decreases continuously. So this decrease in amplitude is called damping, and the motion is called damped harmonic motion. I am repeating. Whenever a body is oscillating, its mechanical energy is not a constant. We have taken assumption that it is a constant, but practically it is not possible. So since energy is lost, its amplitude decreases continuously. So this decrease in amplitude is called damping, and the motion is called damped harmonic motion. And for this damped harmonic motion, equation is given by F equal to minus kx minus bb. See carefully. Earlier what we have written, I am writing here. Just a minute. Right. So earlier we have taken F equal to minus k into x, right? So here it is m into d square x by dt square. That is nothing but net force equal to minus kx. Now in addition to that, we are taking here minus bv. This is one extra term because of damping. Means energy is lost. For that we are taking here minus b into v, where v is now velocity. And b is known as damping constant. That means for f equal to minus kx, now adding one extra term that is minus b into v, right? Now for this equation, solution is x equal to, for this equation solution is x equal to, see carefully where change is coming, x equal to, earlier we have written here only a, right? Now in the place of a, it is a into e power minus bt by 2m. So this is total one what we call amplitude. This total is called amplitude. And that amplitude is a changing exponential. It is now decreasing exponential. Okay. And you can see here in the place of omega, it is omega dash, which is given by omega dash equal to square root of k by m minus square of b by 2m. So here we are taking these results directly because this mathematics is completely out of our range. So we have to remember this as it is. And here b is very small so that omega dash cannot be negative, right? And next coming to here 2m by b, that is known as damping time constant. I am repeating, 2m by b is known as damping time constant, or it is also known as mean lifetime of the oscillation. See meaning of that. Since energy is lost continuously, after some time body stops oscillating. So how much time it oscillates? We are taking the average. That is what is here, mean lifetime of oscillation. Okay, right. Now see carefully the mechanical energy of the oscillator is. So earlier we have written Just a minute. Right. So what we're writing here, see carefully, energy equal to half k a square e power minus b t by f. Earlier we have written half k a square, right? Now in the place of a, it is a into e power minus bt by 2m. So it is again same form, no change in that. Just replace a value with a into e power minus bt by 2m, right? So energy is a half k a square into e power minus bt by m. So this is what we have to remember while solving problems, right? Let us see next one. It is forced oscillations. The name itself indicates a body is oscillating under the action of an applied force. I am repeating. A body is oscillating under the action of an applied force. It is also a periodic force. We can see that here. See sentence carefully once. If a body is oscillating, if a body is oscillating under the action of an external periodic force with a frequency equal to frequency of external force, then those oscillations are called forced oscillations, right? So body oscillating under the action of an external applied force, right? See equation for that. The equation of motion of the body. You just compare with the previous one. We have taken one extra force, that is F naught sine omega t, which is a periodic force. F naught sine omega t. And solution for the above equation is x equal to a sine omega t plus 5. This is solution. And in that a value is given by f naught by m by, here square root is for complete one. This is for complete one. Omega square minus omega naught square plus square of b omega by m, where omega naught is natural angular frequency. This is what we are knowing, root of k by m. And omega is frequency of the periodic force. Now see carefully in this amplitude, if omega equal to omega naught, if omega equal to omega naught, then amplitude becomes large. And in addition to that, suppose B is very small. If B is very small, it becomes very large. See the meaning of that. Omega equal to omega naught. Its meaning is frequency of the periodic force is matching with natural frequency of the oscillating body. Then body oscillates with more frequency, with more amplitude. That is what we call resonance. See here sentence. If the natural frequency of the oscillator is equal to the frequency of the external periodic force, then it oscillates with a larger amplitude. And this phenomenon is known as resonance. So whenever frequency of the body and frequency of the periodic force matching, it oscillates with a larger amplitude. This is what we call resonance. Okay. Now let us focus on problems basing on this. Right. See question number 1. The amplitude of a damped oscillator becomes 1/3 in 2 seconds. The amplitude of a damped oscillator becomes 1/3 in 2 seconds. If its amplitude after 6 seconds is 1 by n times the original amplitude, then find n. So he is speaking regarding amplitude after some time. Okay. Then see what we have learned here. Amplitude is equal to A naught. This stands for amplitude when time t equal to 0. E power minus bt by 2m. Okay. So when t equal to 2 seconds, A becomes A naught by 3. So equation 1 you can see here. A naught by 3 equal to A naught into e power minus in the place of t 2 seconds. So minus 2b by 2m. Right. Next. When t equal to 6 seconds, given it becomes 1 by n times. 1 by n times. So it is A naught by n equal to A naught e power minus 6b by 2m. So solving these two, we are getting n equal to 27. So I will make calculation here. Take here equation 1. Equation 1 by equation 2. Then see what we get. We get n by 3 is equal to n by 3 is equal to, let us take e power minus 2b by 2m. Okay, that as x. That as x by, it is now x cube. See carefully. I have taken e power minus b by m as x. Then e power minus 3b by m becomes x cube, right? And this is equal to 1 by x square. And see here what is the value of x. Here x value, it is 1 by 3 from equation 1. Okay. X value 1 by 3 from equation 1. Now substitute that here. Okay. Then we are going to get n equal to, it is 27. So x is 1 by 3. So n becomes 27. Right. You can see now almost same kind of question. Question number 2. The amplitude of a damped oscillator decreases to 0.9 times its original amplitude in 5 seconds. In after 10 seconds, see carefully, after 10 seconds, that means total time how much? 15 seconds. Okay. It will decrease to some value given here. Then we have to find the value of alpha. Then say what we have written here. At t equal to 5 seconds, given 0.9 A naught, that is equal to A naught e power minus, take a t value 5, minus 5b by 2m. At t equal to 15 seconds, A equal to A naught e power minus 15b by 2m. So same as question number 1, and you are solving that, going to get alpha equal to 9. Okay. So 1 and 2 both are same kind of problems. Right. Let us now come to question number 3. A pendulum bob of mass 1 kg with a time period of 1 second is losing energy due to damping. At a certain time, its energy is 45 joule. If after completing 15 oscillations, its energy becomes 15 joule. Find the damping constant in SI units, right? So taking directly here energy equation, what you call that? Energy, what we got? E equal to, it is a half k a square. Take it as E naught, half k a square. Remaining is now e power minus bt by m. So take in the place of e, it is 15. In the place of e naught 45, it is e power minus 15 oscillations means you are given time period is 1 second. So 15 oscillations means 15 seconds. So 15 b by m, and m value is 1. So now we have to solve for b, which is known as damping constant. Okay.